Phew, I just wrote this code. How much time has passed? Well, I don't think I forgot anything, so I think I need to write the tests.
No, you can write unit tests, but you've already checked everything. Why check again and burden yourself with more work? It works fine without tests because it already works. You've checked it.
Well, yes, that makes sense.
Stop. Don't listen to him. Yes, you will spend more time, but in doing so, you will test the functionality. Be confident that everything works as you intended, and there will be fewer potential bugs and errors. Therefore, don't miss out on such an opportunity.
Well, that's true too. It is still desirable to write tests.
Here he is now, but why? He wants to load us up, to work, to submit everything, and it's all fine. Let's go relax instead. Well, if I'm happy that you will be writing tests, we will go relax there after some time. Why? If you can submit it now and go relax, then go ahead. No one will notice that you didn't write the tests. Everything is fine.
Well, yeah, that's true. Anyway, whatever, I guess I'll just submit it like this. Indeed, no one will notice anything and everything will be okay. So let's send it. No. But this is what happens if you don't write unit tests. Now let's break down what unit testing is and why it is so important for development. Unit testing is a testing method in which we check individual isolated parts of the code. Typically, these are functions or methods. The purpose of these tests is to ensure that each unit functions as intended by the developers. What are the main advantages of unit tests? 1. Easy to locate errors. 2. Simplifies code refactoring. 3. Contributes to a better understanding of functionality. 4. Increases confidence in the stability of the application. It is important to understand that unit tests check only specific methods or classes. If a test involves the interaction between multiple classes, then it is no longer unit testing, but rather integration testing. We already have a video on our channel about integration tests. Here's what is important to consider when writing a unit test. The test should be isolated from other components. One test is one check. Tests should be reproducible, and they should be simple and readable. For Java, JUnit and Makita are most commonly used. JUnit is used for writing the tests themselves, while Makita is used for mocking dependencies. So let's move on to the practical part. So let's start writing the tests. Before we begin writing the actual test, we will add one more. We will add a setter here, a setter from Lombok. We need this to set a secret here. In unit testing, we need to set a secret here. Otherwise, nothing will work properly. For this, we set a setter here. This is not needed for integration testing. So what we do is right-click, generate, test, and all tests, except for the set, of course. Super. And to start, let's add the JUnit service here. Private JUnit service. But we will add the inject mock annotation here. This annotation tells Makita to automatically create the object. Alright, next, private final string email. We will need this email for the tests. So let's write something like test123@gmail.com. Great! In this video, I won't be writing all the tests for our security, but I will write some, and simply show how unit tests are written. Before we start writing the first test, we also need to do something. Public void setup / we write at before each. This is a JUnit annotation that indicates this method will run before each test. Before this, and before this. But why do we need this? Makita.annotations.openmux.this method opens all of the required and essential resources necessary in order to testing. Although we do not mock dependencies, this call in the context is useful for proper initialization. Next, we install JUnit secret. Let's copy the value directly from here. Prep done. Start writing the test. JUvt-authentication.ru equals JUvt service generate auth token email. Yes, he is currently complaining that I could have put all of this here, but we will be using this email practically everywhere, so we will leave it as is. We write suc files, check the email, and now it's interesting to use jvtservice.getEmail from token.jvtl.sync.html.getToken. This way, we will really ensure that this token was generated specifically with our email. In other words, it is not just some random token. It is definitely our token that we generated using this email. We can also check for validity. Yes, I use different methods from our service for this. In other words, it doesn't quite resemble unit testing anymore, but essentially that's how it is tested, because we need to ensure that the token was generated, that the token is valid, and that the token was generated specifically from our email, not just from somewhere else. Accordingly, we check it this way. Technically speaking, we could write separate implementation methods here for verification, obtaining the email from the token, as well as for token validation. But why do this if we already have everything in the service? Therefore, we can easily take it from there and check. We run all the tests. We run the tests separately. Great, everything worked. Let's continue. Now it gets a bit more interesting. We'll repeat the same thing. Let's just copy it directly. We need to get a token first. Then we need to get another one. What should we call it? New JUnit service refreshBaseTokenML and get refresh token. That's correct. Probably this way will be better. And ideally, now we should do it like this. Assert equals we need to check that the refresh tokens match only here in the view. And we also need to verify that our base tokens do not match since we are using the refreshBaseToken method not equals getTokenJWT. In order to ensure that the tokens are indeed correctly and accurately verified as expected in this context, we must be thorough. GetToken seems fine, but there will be a small problem that we'll see now. It says that it is expected to be unequal, but in the end, it is the same. Why is this happening? Yes, it's all because we generate based on time. We take time and generate it. Accordingly, since our base token update is the same as obtaining the base token, that's how it happens. This won't be the case in a regular application. What do we need to do? This is a bit more interesting. As I mentioned, tests should pass quickly, but in this particular case, without a little waiting, we won't get a correct result. So what do? We make it sleep for 1000 milliseconds. Right, I forgot. You might have thought that 100 would be enough, but 100 won't be enough. He won't have enough for 100 milliseconds. He will say that they are also equal, so 1000 is absolutely sufficient. Now they are not equal, as the token generation occurs slightly, but with a delay. We check all the tests. Great, all tests passed. Okay, now let's do it this way. Now let's do all the same things. We will generate with our email purely technically, but there is a possibility that we could skip testing. However, since tests are required, we will write all the tests. What we do is check these two lines. Basically, we don't need anything more. The test has passed. We run all the tests. And by the way, refreshBaseToken has a slight delay, did you notice? This is related to the fact that he is a bit sleepy. So, now we validate the JUnit token. We also generate it and assert that it is true. Great! We can also do this and check that the token will be invalid. Well, for example, since getToken is a string, what will we do? We will duplicate negative test. Let's add the suffix test everywhere here, in this context, and thoroughly. Alright, great! This will be a negative test. So how will we get this negative test? I will do it a bit cleverly. I will display the token that was generated for a specific time. Here is this token. I will copy it. I will remove this. And so we will insert the token in a manner that is like this, hopefully. I hope it will handle it correctly and efficiently. Honestly, I must remember how long this token is valid for. It's approximately a minute. So we need to wait about a minute and then run the test, because if we run it now, it will likely say that the token is still valid. Yes, it is indeed expected to be false, but it is actually true, so we will wait a little bit and see. So, a minute has passed very quickly. All tests are working correctly, that's all. Let's run all the tests one more time. Great, now, let's run it in coverage mode and see what we have with coverage mode. Let's go into the service and take a look. We only had some errors that did not pass, although there is one that did pass. It just so happens to be expired. We checked all the others. Even these private methods were covered since they were used in these methods. And this is how we tested our JWT service. The methods are covered 100% with line coverage at 82%. So these can still be covered separately, I think, just by provoking those exceptions. Well, that's basically it. Now you know what unit testing is, why it's needed, and how to write them. If you like this video, don't forget to give it a thumbs up, write in the comments what topics you would like to see videos on, and be sure to subscribe. Thank you all for watching, and goodbye.